10 questions in quiz 3 first, then the remaining questions in homework number 1. Yeah, excuse me. Yeah. Yeah, but all right. Yeah. The first question in quiz 3. Yeah. If we can solve a computing problem using both iterative and recursive, which one uses more? In general, recursive. Yeah. Because recursive, we need to consider the special internal implementation way. Yeah. So I explained in the notes, a special data structure stack is used for implementation of recursion. All right, yeah. And the stack could be deep. Could be deep. So when you implement a recursion, yeah. So in that consideration, a lot of memory resource is used. Yeah. So that's the biggest drawback of recursion. Yeah. So then in our consideration, sometimes we try to avoid recursion. Yeah. Sometimes for relatively simpler cases, if we can use iterative method in our implementation, we try to reduce the chances that we use the recursion, yeah, but we also consider in relatively more complicated cases, we do not want to, completely avoid recursion, yeah, because in that situation, it will be too complicated, yeah. So we still, we like the power of the recursion, but sometimes we want to save some memory resource. Yeah. So that is the, basic consideration between these two methods. Yeah. All right. Yeah, let me just turn off my cell phone. Yeah. Okay. All right. Question number 2, which of the following categories does the recursive algorithm we use to solve count binary digits problem belong to with respect to the given number n? Yeah, the binary digits, that problem, we have solution big O of log n, yeah, because I remember a formula, so we count the number of binary, yeah, number of additions. We have that formula, 1 plus floor function of log base of n. Yeah. So that is the growth function. You know, that is the leading term of the growth function. Yeah. So you need to be familiar with the basic formula. Yeah. It's a simple question. All right. Yeah. Next one. Which of the following statement about a golden ratio is correct? Irrational number, right? Yeah, because the golden ratio, we know it equals this expression, and the root 5. Root 5 is an irrational number. Rational, irrational. Yeah. In number theory, remember, in number theory, in the number theory, there is a famous question. Yeah. Show that root 2 is not a rational number. If you go back to your discrete math 3000, you have one chapter, early chapter about number theory. Yeah, actually, when you learn that a special method called a contrapositive method. Yeah, so when you learn that, this example is given. Yeah, that one, root 2. But you can use the same way to show that root 5 is also an irrational number. Not irrational, so that is irrational number. Yeah. All right. Yeah. So if you know this concept, so then it is very easy. Yeah. But you do not need to show. In this question, you do not need to, prove it. Yeah. Here, I just give you the background. Yeah. Number 4, when we calculate the greatest common divisor of the two positive integers, two methods. So we compared prime factorization method and Euclid's algorithm. Which one is better when two positive integers are huge? The answer is Euclid. Yeah. Because the prime factorization, this method, very slow. Yeah. When given integers are huge. Yeah. And this property, this prime factorization, extremely slow. This property, so I'm talking about the property, okay? So the property, what property? The prime factorization, factorization is extremely slow. This property is very useful for encryption application, right? Yeah, think about encryption. Currently, for our communication, internet communication, encryption is extremely important, right? Yeah. In order to protect our data, every time the data sent through internet is encrypted. So that encryption using a special encryption algorithm called RSA algorithm. RSA, encryption decryption algorithm. And that algorithm is based on, number theory. Number theory. There is a theorem, a theorem in number theory. Theorem. Yeah. Based on one famous theorem in number theory. So what's that theorem? That's the theorem. Yeah. Let me quote here. Little yeah. Little Fermat. Little Fermat theorem. We know there is a big Fermat theorem, okay? But this one is the little Fermat theorem. Yeah. And there is a formula for that. Yeah. Using the little Fermat theorem, if we know some big integer keys, we can do factorization of one big number easily. Yeah. But because when we do encryption, there is a secret code. We do not, there is a public key and a private key. Yeah. So if you learn the coding theorem, there are two keys. One is called a private key. Another is called a public key. Okay. The public key provided to people. Yeah. But private key cannot be provided. Okay. Yeah. So you have to deliver private key in a secret way. Yeah. All right. But if you have that private key, then you apply the little Fermat's theorem, you can decompose a big integer quickly. Yeah. But the hacker, so let's think about the hackers. The hacker, although they have the public key, but they do not have the private key. So they cannot apply that little Fermat's theorem. Yeah. So they have to do prime factorization directly. Okay. Yeah. Then it is extremely slow. Okay. Yeah. It is very hard to break it. Yeah. But for the side with the private key, you can avoid prime factorization because you just apply this little Fermat's theorem using that private key, so you can find the decomposition easily. Okay, so that's the idea. Yeah. So this property, although if we want to do prime factorization, it is not very good, but people can use this property to protect our data on web. Yeah. So from this point of view, it is a very important, useful property. Yeah. All right. Oh, yeah. I just make some mess. All right. So, yeah. Next question. Oh, yeah. Number 5, when we apply a recursive algorithm to solve the Fibonacci. Yeah, I mean, this one also check your on if you are familiar with the notes, the content. Yeah, the answer is yes. Yeah, the answer. Remember, we have several methods. Yeah. So the answer, there is a recursive algorithm to solve Fibonacci problem. Actually, remember in our method, if we call, yeah, so here, let me give you the numbers in those methods. Yeah. So remember, there is one method. What that one with, it's a recursion with a lot of redundancy. That one is big O of exponential. Yeah, that A is the golden ratio. A equals that golden ratio. That one. But other than that, we have improved methods. So let me write this way. Those without redundancy. We have two methods, 2 or 3, yeah, actually, yeah, 2 or 3 without redundancy. All those methods in this category, linear. Yeah. Yeah. Actually, there is another one in our textbook. Yeah. Another one in our textbook. Based on a special formula. Okay. Yeah. So that's based on special formula. That formula using this matrix. Yeah. Very special matrix. Yeah. That one, big O of log n. Yeah. So that one is very interesting. Yeah. Actually, I'm thinking about to put it in our project number 2. Yeah. Here, yeah, related to project number 2, I may post, some update. Yeah. Yeah, because here in my plan, I may like to reduce the workload for you. Yeah. For the remaining of the semester, I've tried to reduce your workload a little bit. Yeah. So one way to reduce, I may like to make the project number 2 as optional project. Yeah. So not required, optional. Yeah. So that's one way to reduce. Another way I can reduce your workload. So for the midterm test questions, I will give you 20 questions, not 25 questions. So yeah. So this is another way to reduce your workload. 20 questions. Not our usual 25. Yeah. Yeah. So the same amount of time, yeah, but just the 20 questions. Yeah. All right. And yeah, I try to find a way. So we still cover the same content, practice, uh, test, but reduce your amount of work slightly. Okay. Yeah. So, all right. Yeah, next question, number 6. Greatest common divisor problem. We would like to use problem size reduction method. Which of the following tools is the key for the success of this method? This question is designed to check your understanding. If you are familiar with our notes, now in the notes, when I explain the Euclid's algorithm, we use another fundamental theorem in number theory. Yeah, also fundamental theorem, number theory. Yeah, so that is the division algorithm. Yeah, very simple, but very useful. Yeah, so this algorithm so simple because integer division, everybody knows. Even the primary school students, they know the integer division, right? How to do integer division. But very useful in number theory. Okay, yeah. And our GCD, the Euclid's algorithm, is based on integer division, the division algorithms. Okay, yeah. All right. Then the concept. So this one, I like to check your understanding of the linear combination of X and Y. Yeah. If you follow, yeah, so here still in the notes, yeah, so you can see many questions are designed to check if you are familiar with the content of in our notes. Yeah. So this one is another one. That's the linear combination. Yeah. Actually, you can see those. All right. We have Maria join us. All right. Good. All right. Yeah. So you can easily remove those options that contain some square term, yeah, and the linear combination. And when we solve linear recurrence relation, yeah, when we solve the a type of question, this question, so linear recurrence relation. Okay, yeah, we need to use this concept, linear combination of two solutions. So what actually we use the linear combination of two special solution to form the general solution. That's the background of this question. Now, So the concept is very simple, but when we work on this type of questions, it is critical. This step is critical. Okay, yeah. All right. Just the background, yeah. So many questions, you need to have the background when you answer those questions. Yeah, otherwise you may feel strange. Why we have these questions? Yeah, because in my notes, in my lectures, I give you a lot of background. Yeah, so some of the questions I design to check your understanding of the background. Yeah. All right, next question, number 8. Is it possible to apply the dynamic programming algorithm? I believe many students, they may not be familiar with this concept. We have a short introduction on dynamic programming when we learn the Fibonacci numbers. Yeah. So when we, here I just point out a little bit. Yeah. Remember, we want to remove redundancy. When we calculate Fibonacci numbers. And we use a special method. We use a special method called use the dictionary method. The method is called dictionary method. So we create a dictionary. So what kind of dictionary? The dictionary actually, it is just an array used to store the known, another student, store the known Fibonacci numbers. Okay, Fibonacci numbers. Yeah. And that method, we call it dynamic programming algorithm. Yeah, dictionary method, basically a dictionary method. Yeah. All right. So here you see this word programming, dynamic. So keeps changing. Yeah. The data stored in your dictionary keeps changing. So we call it dynamic. Okay. Programming. What's the program? So here the programming, it's not coding. Yeah. It's not the meaning of our usual programming, we mean the coding, right? But here, programming, not coding. Yeah. So its meaning is old meaning. Yeah. People used, long time ago. So the programming here just, make a table to store info. Okay. Yeah. So this is the meaning of that programming. Okay. Yeah. So it's a early time meaning. Okay. Yeah. Yeah. Recently, people do not use this meaning as for programming. Yeah. But in a very old time, people use this meaning. Yeah. Make a table to store information. Yeah. And here we need to use that the meaning of the programming in this place. We need to use this meaning. Okay, yeah, because we need to make a table. Our dictionary is the table. Okay, our dictionary is that table. So the dictionary method refers to that, programming way, old programming way. Yeah, not the coding programming, the table programming way. Yeah. All right, so this is the background. Next question. When we solve the count-binary digits problem for a given positive integer n, which of following ways give us the correct answer? Yeah, floor function, ceiling function, right? Yeah, here, the formula, yeah. So, yeah, because in the middle, we compare. Yeah, we need to make a guess. Yeah, remember, so here, I just recall the background for this question. Make a guess. When we try to make a guess, we have two ways to make a guess. One use floor function, one use ceiling function. Okay, yeah, because we know, yeah, the reason is why we make a guess, right? So you may ask why we need to make a guess here, because first we consider n is power of 2. When n is power of 2, we get a formula 1 plus that one. Okay, so this function, it is an integer. It is an integer. Okay, but when n is not power of 2, then this log base 2 of n is not an integer. Okay, so we need to convert it to an integer. Convert it to an integer function. Yeah. Here, two ways to convert a non-integer function to an integer function. Yeah. But which one is correct, right? Which one is so we need to check it. When we check, we take n equals 3. We plug in and we can see, yeah, the answer is the floor function version is correct. The ceiling function way is incorrect. Okay, yeah. So this is the background in our notes for question number 9. Yeah. Otherwise, you may wonder why we have questions like this, right? It is pretty strange. So here you can see typically in our quiz questions, many questions are designed to check you if you are familiar with the notes, the content of the notes. Yeah. In our homework assignment, then usually I do not give you many questions like this. Yeah. So I focus on the problem solving part. Yeah. So you need to, develop your problem solving skills in our homework questions. Yeah. But in quiz questions, you need to have the sufficient background knowledge in order to do a good job in this class. Okay. All right. The last question of quiz number 3. Yeah. When we solve a computing problem, if we guess the result that is very close to the real result, it will be very helpful for us to solve the whole problem in a lot of situations. The answer is true, is correct. Okay. Yeah. actually that is, yeah, so this method, actually this, because the guess basically, we treat it as a prediction. Very close to the real result, that means your prediction is very good, okay? You make a very good prediction, okay? Then you can apply many tools to verify if your prediction is correct or not. Yeah. So we can apply here one way. Yeah. So we use this way a lot. So we can apply the mathematical induction to verify our prediction. Okay, yeah. So that's the strategy, okay? Good strategy. Yeah. So this is, actually this strategy is very powerful. Yeah, very powerful. Okay, yeah. All right, so that's the 10 questions for quiz number 3. Yeah. Next, we need to move to homework questions. Here, I select those relatively hard questions first. Yeah. For relatively easier questions, yeah. If I feel I need to explain something, I will make some video. Okay, yeah. Especially after I do the homework grading. Yeah, I haven't. Yeah, but I will do it quickly. Yeah. Actually, tonight, yeah, just give you updates. Yeah, because based on our plan, we will start midterm tomorrow, right? Friday. Tomorrow, Friday, and I will give you 4 days. Okay, so here, so based on our plan, our midterm starting from tomorrow, Friday. Yeah, Friday. Friday, yeah, with 4 days. Okay. 20 questions, not 25. Okay. Yeah. That means I need to post those 20 questions sometime very late tonight. Yeah. So usually I work very late. So very late tonight. So tomorrow morning, yeah, tomorrow morning. So when you check Canvas, so you can find these 20 questions. Then you can start work on these 20 questions. Yeah. These 20 questions, basically I modify the questions from 3 quizzes plus 1 homework assignment. I do some reasonable modification. Yeah, yeah. All right, yeah. But some variation, modification could be challenging. Okay, you can expect 2 or 3 questions relatively more challenging. Yeah. Okay, but for those challenging questions, I may create some hint videos for you. Yeah, hint videos. Yeah. All right. So let's move to those hard. Yeah. Yeah. These are the you know, last time, oh, I already explained last time. Yeah. So now I just add a few more slides for the today's new explanation questions. This one in my hint, yeah, I give you partial hint, yeah, but later I do not want to give you too much information, yeah, because with the given information, actually you can find the answer, yeah. But you need to make the last critical step, yeah. All right, so here, remember in the hint, we draw a line like this, and we consider position index I, the element A of I, let's write in this way, A sub I and A sub J, okay, location. Then, for your visual understanding, this line segment is divided into three areas, three regions we can consider, okay? Yeah. Region 1, region 2, including X, AI, AJ, region 2, and region 3. Yeah. Then, when you do swap between XI and XJ, yeah, a swap between AI and AJ. Then we consider the change on the number of inversions. Yep. Before we do that swap, we have certain number of inversions, right? Okay. Then, after this swap, we have another number of inversions, two different numbers, and we compare the difference. Here, you need to use some abstract thinking in the analysis procedure. All right. Think about, because for a typical inversion, for a typical inversion, here I assume you are familiar with the concept inversion. Okay, so I do not explain what's the meaning, what's the definition of inversion. Yeah, so we have done so many inversion questions. So I assume you are very familiar with this concept. For a typical inversion, for this pair, XY pair, right? XY pair could be an inversion, could be a non-inversion, right? When, yeah, so here specifically, when X less than Y, not an inversion. Okay, when X greater than Y, yeah, less than equal, yeah, we can, greater than Y is an inversion. Okay, yeah. So that's what we mean. Yeah. So we consider a typical pair. Okay. Yeah, actually, a typical pair for the inversion. Yeah. To write it better, yeah, this expression should be. Yeah, let me just modify. Yeah, change for a typical pair. Why we consider a typical pair? Yeah, typical pair, XY pair. Okay, so typical pair, XY pair for the inversion. Okay, now then think about different cases. The case one, X is in region one. Think about if we assume X is in region one. Actually, more accurately, let me just say X is in region one. Okay, no matter where Y is, right? Y is in region 1, 2, 3. No matter where is the real location of Y, no change after the swap, right? Can you see that? No change. No change after the swap. Okay? Yeah. Where X is in region 1. Okay? So if your Y is in region 1, before the swap, after the swap, the inversion status has no change. Can you see it? All right. And then if Y in region 2, consider the inversion status in XY pair before the swap, after swap, is there any change? No change, right? Yeah. And Y in region 3, before the change, after change, also the inversion status for XY pair has no change. Can you see that? Yeah. Try to get this because this is a critical step for the number of inversions. Critical step. Yeah. All right. Then let's consider. All right. When X is in region 3, the same thing we have. So no change after the swap, right? Okay. Yeah. Yeah. So here you may argue why you consider X not Y. Yeah. Actually, Y is also okay. Okay. If you replace X by Y, also okay. Okay. Also okay. Yeah. So then our last observation, critical observation, that's why important. Yeah. Only when X and Y are both in the region 2. Region 2. The number of inversions could change. Right? Yeah. That's the key observation. Okay, number 3. Yeah, but this key number, this key observation comes from after the first 2. Yeah. So here you can see only the pair to be considered in region number 2 that could be affected by the swap. Could be affected by the swap. Oh, yeah, I'm sorry. Yeah, suddenly it becomes dark. I forgot to connect my power adapter. So the battery could be very low. Yeah, so here I connected to save the interruption situation. Yeah. Yeah. Look at that. Okay. Look at these 3 observations. Yeah. There you are very close. Yeah. After you make these 3 observations, now you are very close to get an answer. All right. Now move to this maximum number inversions. How to make that number maximum? How to make the number of inversions maximum. Okay, yeah. Maximum, that means the larger the region 2, the larger the region 2, the larger the inversion number. Right? Okay, yeah, the larger. So we consider largest possible case. That means region 1 is empty. How about that? We shrink region 1. We shrink it to make it empty. That is the smallest possible region 1. And we also shrink region 3 to make it empty. Yeah. Then the whole array belongs to region 2. Think about that. The whole array elements belong to region 2. Okay. That means AI corresponds to the first element in the array, and AJ corresponds to the last element of the array. Basically, we just swap the first element and the last element. Then we count the number of inversion chains. All right? Yeah. Then the first element here, yeah. How about let us just use our element 1, 2, 3 through n for these n elements. Actually, these numbers also represent their order for convenience. How about that? Okay, so we can do that for convenience. All right. Okay, yeah. Then when you do swap, think about this case and this case. You count the number of inversions, the difference. Can you count? Count and compare the difference for that case. What is your answer? What is your answer? Okay. Yeah, so the answer is 2n minus 3. The number of inversion difference. Yeah, because in this one, the inversion number is 0, right? Yeah. And this one, inversion number, you just come with respect to n. What is the inversion? With respect to n. Yeah, so here, if you consider n and another element, you look at inversion, that's n minus 1, right? Then with respect to 1, but when you consider with respect to 1, you need to skip that n because n is already used before. So when you consider 1, you have to skip n. Then you look at the number of inversion. That's n minus 2, right? Yeah. So you're adding together, so you get 2n minus 3. How about that? How about that? Okay. Yeah. But you need to do analysis by yourself, like this slide. That's not easy. That's not easy. Yeah. That's very hard. Yeah. But at least I point to the right direction for you. Yeah. But here you can see, yeah, this is probably, this question, probably the hardest question in this assignment. Yeah. But I like you to solve it by yourself. Okay. Yeah. All right. Yeah. We only have about 5 minutes, 5 or 6 minutes left. Yeah. So I just do another question. Yeah. This question, yeah, not very hard. Yeah. Although I put it as the last question, but yeah, but actually I like you to draw a diagram. Yeah. Then it should not be very hard. Okay. Yeah. So let's say A1, A2 in order, A3, B1, B2, B3. Okay. Yeah. In my hint video, we know A2 less than B2. In my hint, I already gave you a lot of information. Yeah. So here I do not repeat that part. Yeah, because yeah, so we can save some time. Yeah. All right. The third, yeah, I remember in my hint video, the median equals the third smallest. And also the fourth largest, right? If you look at the largest direction, fourth largest. So we use these two position information pieces to help us do the elimination. Okay, all right, yeah. First, let's look at step 1. Let's look at A1. Yeah. For A1, we can say less than A2, less than A3, yeah, but also less than B2 through A2, right? Yeah, because B2 through A2 and less than B3. Yeah, so you can see, you can find 4 elements. 4 elements greater than A1, right? Yeah. So now let's draw this, the final order diagram. Yeah. Third, yeah, position here. Okay. Yeah. But you find 4 elements greater than A1. So conclusion is A1 cannot be the median. Okay, yeah, because the median, this is the median. Yeah. All right, yeah. Second, look at the B3. Yeah. B3 greater than B2 greater than B1. All right, yeah. And a B2 greater than A2 greater than A1. See, B3 is greater than 4 elements. Yeah. All right. Yeah, but the median can only be greater than 2 elements, right? So this gives you that B3 cannot be the median. All right, yeah. There, look at the B2. Okay. B2 greater than B1 and greater than A2, A1. And the B2 is greater than at least 3 elements. So you can see, because the median can only be greater than 2 elements, right? But you'll find that B2 greater than 3 elements. So B2 cannot be the median. All right, yeah. So there, the remaining 3 elements, B1, A2, A3, there, you cannot eliminate, okay? With the given information, yeah, so you can try a little bit. Yeah, actually, if you want to make a rigorous conclusion, you can make an example. Can you make an example following the given information such that B1 is the median? If you can find example there, B1 cannot be eliminated. Similarly, can you make an example to make A2 the median and without any violation for the given condition, then A2 cannot be eliminated. And similarly, A3. So if you want to make the rigorous conclusion, then you need to create 3 examples for B1, A2, B3. Then at the end, you make your final conclusion. Okay? Yeah. So the only elements that you can, yeah, so the elimination elements, yeah, these 3, yeah, A1, B2, B3. Okay, yeah. All right, yeah. So that's the relatively hard questions in this assignment. Yeah. Then after I do the grading, I will see your problems. Yeah. So I will send your graded paper back through Canvas. Yeah. So you will see it. So I write it. I use my pen to write the grading information on your paper. Yeah. On your file, on your so you can see my grading comments on your file. Okay. Yeah. After that, if I need to make comments for the whole class, so I will create a video to talk about selected questions in the remaining homework questions. Yeah. All right, so let me stop right here. Yeah.